You're watching the Mission X overview. Why don't we take a look at the Mission X activities and how they relate into space. Mission X has two types of activities. We have physical activities and we have educational activities. Your physical activities can be done anywhere, outside, in a gym, anywhere that you're able to get enough room, and also they're flexible. So you can adapt them to your resources, to the materials that you have, the number of children. The whole idea is to get children moving and having fun. I'm talking about physical fitness, space.
Training like astronauts.
Exactly. Everything about space and having fun and getting healthier.
Exactly.
And the second part are educational activities, which are also very flexible, but they are more like an experiment, I would say, Nubia?
It's more like science activities, but they're the science behind the physical activities. So here you get to know about your nutrition, about your body, how it works, and what you need, and things like that.
No, that's really important because we everything that we do around to go into space has a good science background, and they go together. Physical in the classroom, and then this education is really do a little good gap in between the two of them.
Exactly.
That puts it all really together, so fills that gap. So why don't we go ahead and take a look at those educational activities first, and see what we can find in the documentation and how they relate into space.
Definitely, let's do that. So let's look at the educational activities. In the educational activities, you'll find two handouts. The first handout that you will see, it will be a handout for the educator. And this handout for the educator, you'll find things like your standards, your materials that you're going to need, how to prepare these materials, and ways that you can actually implement this in your classroom or your setting. Then you also have a student handout, and this student handout is actually for the student. And we try to give them information that they might need, like why are they doing this? And what kind of data observation pages they're going to need in order to write down the information. Okay. Both of these are available for you, again, on the website. So let's take a look at one of our activities more closely. Let's take a look at the one that says Energy of an Astronaut. Here, you'll see that all of our activities have like a problem. And here we're trying to find out the relationship between calories that I take in and how much I use. And you can see here, you can see an image of a display on what children are doing. We actually created the food pyramid on the floor with masking tape, and children here are actually categorizing the different types of food. It's lots of fun, it's visual, and it's big, and kids get to manipulate this. It's a great tool. Now let's look at the space relevance.
So we know that eating good nutrition, we just learn about the different food groups and how consumption, it's very important to keep us healthy, to keep us, getting our whole body working the way they're supposed to be working. So in space, it relates to a couple things. The first one actually, which surprises a lot of people, is there's a social aspect of it. So astronauts, while they're in the International Space Station, they gather together at mealtime to have a social event. Just like we do with our families, with our friends when we go to the park, or when we are in the lunchroom at school. We'd like to do that. We'd like to converse over food. It is something that's very important for our astronauts. But the other thing that happens is that for us to keep ourselves healthy in space, because even though we're floating around, space is actually a very challenging environment to be at. And we need to have all the right nutrients, the right calories, and everything that we need to keep our bones, our muscles, our hearts, and everything on our bodies functioning right and healthy.
Plus they need to do their job, their task.
That's exactly right.
They need the energy to do that. Let's take a look at our next educational activity, Living Bones and Strong Bones. Here students are going to make a bone model that resembles a real bone.
So it has to be strong, maybe?
Yes. Has to be strong, and has to be able to hold your weight as well. As you can see in this image right here, you have students that packed up different books to see how strong their bone is. Okay.
That's a lot of books that there's children to have in here.
Oh yeah, that's a pretty tough bone right there. Yes. But how does this have to do with space?
Well, bones are actually very important for us as we go and learn to living in space. And the reason that we actually it's important for us is because when we go into space, we don't use our bones, our lower extremity bones. We're floating around, and the body then says, I need to get rid of some bone strength by getting rid of calcium. And that gets into the messaging system. So we get weaker bones, and what we do is we use activities such as exercise and nutrition to keep our bones healthy. So in the International Space Station, we got 3 exercise devices that we are actually utilizing to keep our bones and healthy, and we combine that with nutrition. So by eating the right vegetables, the right fruits, the right, drinking your milk, drinking other things that you have, you're actually improving that. Those are what we call countermeasures, or we come things to fight against the loss of bone.
Let's take a look at our next educational activity, hydration station. Here the students create simulate urine to be able to identify the different levels of hydration. In this activity, Jamil, they actually get to know about when they are hydrated and when they're dehydrated. So they actually come up with these different types of simulate urine, and so they're able to kind of detect which level of urine shows that your body is hydrated or dehydrated.
So they come in to create this simulation of the urine that comes in different colors? Is that what it is?
Exactly.
Okay.
That's what it is. Yeah.
And that represents, so that's something that for our astronauts actually is very important too. While in space we need to have our normal consumption of water, so we do teach our astronauts and train them into consuming the right amount of water and what does it look like when you're dehydrated. Because in space, as we're floating around and we have things happening to our body, our astronauts don't feel thirst, so they forget how to to drink water. So we got to remind them to do that, and they also are trained to look at what does it look like, what does it feel like to be dehydrated.
It's funny you say that because it happens the same thing with our kids. They forget about drinking water.
So we got to remind them all the time, see, you can continue to be like an astronaut.
Exactly. Let's take a look at our next educational activity, reduce gravity and low fat. Here the students are trying to find out what fat content is inside a cheeseburger, and also find out about balanced meals. As you can see in the picture right here, you can see all the materials that are needed. There are not that many. You need a cheeseburger, fries, a blender, and water, and some beakers, as you can see. And it's a really fun activity because they actually get to blend all this together, and they actually get to see the content of fat.
So they're learning about things that they could, they eat
every day.
Okay,
yeah.
So that tells us what we can consume and what not consume, and how to keep our healthy nutrition up to par. So it shows quite a bit in space. Astronauts have to watch their diet. We talked to them about what do they need to put in their body. Astronauts have a good selection of meals that are actually good in their fats that they need, and they have other nutrients that are going to be going into their bodies. But we make sure that they actually are healthy items that you are consuming at the right proportions that you have. So that's what we learn about the different amount of fats, and the astronauts actually do that, and that way they can work every day, they have the energy, they can perform their activities, and then have a mission success that it's going to make the space flight just go further and further and learn about the universe as we continue to travel.